SQL Service Broker up and running. So if you haven't used Service Broker before, we'll learn a little bit more about it. If you have, hopefully we'll learn something new about it. You guys saw probably most of this yesterday. I'm a consultant. I work in California. The weather is always awesome there. I've written a lot of books. I've written a lot of articles. Get the gist? All right, cool. So let's talk about Service Broker. So anybody here used Microsoft Message Queue or Tomcat or any other message queue technologies before? Okay, so those who just had their hands up, Service Broker, very, very similar. Those that haven't, you have no point of reference. So Service Broker is a lot like any other queuing technology out there. It's asynchronous message processing. Think of it along the lines of one computer sending an email to another computer, and then the computer that received that email does something with it. The what it does part is totally up to whoever programs the stored procedure or the application that receives that message. So it's an incredibly flexible framework that you can use to really do kind of whatever you need to get done, provided that you're not looking for something to happen synchronously. As long as we're okay with there being some sort of delay, maybe half a second, maybe a few seconds, maybe minutes or hours, and as long as we're okay with that kind of unknown quantitative piece of this whole process, then something like Service Broker or another message queuing technology is going to be the way to go. So Service Broker, it has physical objects that store data sitting in the tables, or, which are just tables sitting in the database. But we don't do inserts into those tables, we don't do deletes from those tables, and we don't select data out of those tables. Instead, what we do is we use send and receive, which are two commands that were introduced along with Service Broker. So send is going to be kind of synonymous with insert. Receive is going to be synonymous with doing kind of a select and then a delete at the same time. We can send data through Service Broker in basically any format that we want. We can send any piece of information that we want to send. The most common way of sending data is to use XML. The reason that we want to use XML most of the time is that we typically want to be able to send multiple values all at the same time, and we want to get those values there together as a single piece of information. So the easiest way to do that, to send multiple values, obviously, is to use XML. You can send a physical binary object through XML. Or the person that's come up with a way to do this is Adam Mechanic. So he's got some great scripts on his blog over at SQLblog.com where you can actually do a select statement and take that entire record set, basically that record set object, as a binary object and send it through the message queue. That's going to be more efficient, but that's a lot harder to get set up, and it doesn't demo very easily. One of the really nice things about Service Broker is we have some options as to how we want to process these messages. We can either process the messages on demand, or we can process them automatically when they arrive. So when we're processing them on demand, we can either use a SQL Server agent job, somebody can just log in and run a stored procedure, or an application can log in and run a stored procedure. If we're processing them automatically, the SQL Server will actually run a stored procedure if we want it to, as soon as that message arrives. So the message will basically arrive in the mailbox, or in the queue in this case, and then the SQL Server will automatically fire up a stored procedure, which would then be programmed to go into that queue and receive that message. So you've got a lot of flexibility as to how you can do things, really based on how you want to architect the application that's going to be working along with this. When sending messages in Service Broker, you've got a lot of flexibility on how you want to do things. You can send messages within a single database. So with both queues, with everything happening within just one database within your application. Or you can send messages from one database to another. When you're sending messages from one database to another, those databases can be on the same physical server. They can be on different instances on the same physical server. They can be on different servers within your data center. Or they can be two different companies spread out across the internet that just have a message connectivity between them through their network firewalls. So again, you've got a lot of flexibility based on however you need to set things up. When you're sending these messages, delivery of messages is guaranteed, and it's guaranteed to happen in the order that the messages were received, provided those messages are all sent within what's called a conversation. And you'll see this when we look at the code to get this set up. But basically what we do is we build a conversation, or it's in a logical object called a conversation, and then we send messages tagging them as part of this conversation. So just like we would have a conversation between two people, the server is doing the exact same thing. And all the messages that are sent as part of that single conversation are all going to be sent in the order that they are sent in, and then they're going to be received in that exact same order. So if a message gets stalled because of a network timeout or network lag, the other messages aren't going to get there first. If they do get there first, they're going to be held in kind of a holding area until the one that's being held up is delivered, and then the rest of them will all be delivered in the appropriate order. Now, if you're not concerned with message order, then you can send messages across different conversations, because the same requirement of getting things there in the order sent does not apply if you're sending messages across two different conversations. Message size can be basically as small as you want or as large as you want. You can send null messages, which obviously have no size. You can send messages that are just 1 byte by sending just a single value as part of the message. Or you can send up to 2 gigs of information within the message, all depending on how much data you need to actually send. You're probably not going to want to send really, really big blobs of information through the message queue, because this is all transactionally logged. So every time you send a message into the queue, you are actually writing that information to the transaction log and then to a queue table, just like you would any other table or any other bit of data in the SQL Server database. So if you're sending 1 gig messages, that's a gig of data you have to write to the log and a gig of data that you have to write to the actual database file. So there's a lot of I/O that's going to be involved if you're doing something like that. So there's some important queries that you're going to want to keep in mind when working with Service Broker. The first one, select star from sys.conversation_endpoints. This is going to be the list of conversations that are up and running on your server. So when you create a conversation, you're going to get a couple of rows dropped into this management view. When you close the conversation, those records are going to get removed out of this management view. And you only want conversations open that are conversations that you're actually using. If you're not using the conversation, it's taking up resources in the SQL Server. Specifically, it's taking resources in TempDB, which are very, very hard to identify. If you've got tens of thousands, hundreds of thousands, or maybe even millions of conversations that are open, all these conversations are going to have pages locked in the TempDB database. Because of how they're locked in the TempDB database, nothing else can use any of the data pages in the TempDB database that have a lower ID number than the pages that are being locked by these conversations. So you end up with these really large TempDB databases that are empty and are constantly trying to grow, and you can't figure out why. So you have to go look and see where all these hidden bits are in TempDB, figure out that the problem is being caused by Service Broker, and then simply go ahead and close all your conversations and end them all. And then all this space gets freed up and TempDB can start being used like normal again. The next one you're going to want to look at is sys.transmission_queue. So this is literally just a queue that has all the problem messages that haven't been sent for some reason, or that messages that are in transit from one queue to another. So if I've got 2 servers and I'm sending messages back and forth, and there's a problem sending those messages, maybe the network link is down, or maybe the receiving server has crashed and is being rebooted, you're going to see a whole bunch of messages sitting in this transmission queue, and they're going to give you the actual error message that goes with why that message isn't able to get there. So it's extremely, extremely handy for troubleshooting. And the last thing you're going to want to look at is simply selecting from the actual queue. While queues are tables, we don't look at the actual table itself. We always query from the queue. So if you do a receive on a queue, you'll get the message out of the queue and you won't be able to process it again. Where if you do just a select star, or a select whatever columns you want from the queue, then you'll be able to see the actual messages in the queue, but without processing them. So you can kind of peek into the queue and see what's in there and see how data is flowing through, and look at the actual body of the message and make sure that the data is appearing in the queue exactly how you think it should be. Now, Service Broker was introduced in SQL Server 2005. We had some enhancements in SQL Server 2008, and since then, for the most part, it stayed pretty much the same. So the big changes we got in SQL Server 2008 was this concept of conversation priorities. What conversation priorities do is it literally just lets you say this conversation is more important than this other conversation. So when I'm receiving messages, I receive the messages in whatever order of the conversations that I happen to get them in. So if I've got 3 conversations open, when I go to do my receive, it's going to grab whichever one of those conversations it wants and receive messages out of that conversation. If I set priorities on those conversations, well, now I'm telling the system which one of those conversations I want to process first, which one second, which one third. Conversations can either be set to a priority level of low, medium, or high, or you can use a number 0 through 10, as long as it's an integer. So the classic example that I like to give for conversation priorities is, say I've got an order entry system, very realistic system to have at a business, and I've got VIP customers that are paying me a lot more money, and I've got regular customers that are paying me a lot less money, realistically probably for the exact same service. But I want to make sure that I always process my VIP customers' orders first. So the easiest way to do that would be to use conversation priorities and just have 2 conversations. One conversation for my VIP customers, one conversation for my normal customers. I set the priority for the VIP conversation to a higher priority level. So when messages go into that VIP conversation, they'll be processed first, no matter what, even if there's already messages in our normal customers' conversation. So we process the VIP customers, and then we go back to chewing through and processing all the normal customers. Another application we've got is something called SSB Diagnose. So this is a command line application that can be used to help troubleshoot problems with the configuration of your service broker. If you've never used Service Broker before, you'll understand why we need this application as soon as I start showing you all the objects we have to create to make this whole thing work. The third enhancement we got was a whole bunch of new system monitor objects and perfmon counters. So we got a lot more information that we can now use to troubleshoot and monitor the entire Service Broker application that we've built. We can now track things like how many messages are in the queue, how fast we're processing stuff out of the queue. These are all perfmon counters we can now track, whereas before we had to simply query from the queue to see how many messages were in it. There was no easy way to do it outside of that. So the good news is the slide deck is officially over. Now we're going to go look at some code. All right. Let me grab the code real fast here. So I'm going to do a couple of demos. The first one I'm going to do, we're simply going to send messages within a single database so we can look at the code, see how this whole thing works. And once that's done, then we're going to go ahead and send messages from one database to another. If I can get a new query window open. There we go. Get rid of Object Explorer and make this so you guys in the back can actually read it. Is that big enough? Can you guys all see that? Yes. All right, cool. So we're going to ignore all the stuff at the top. This is just to clean up all these objects every time I run this demo. So the first thing we need to do whenever we're doing anything with Service Broker, specifically between servers, and realistically I wouldn't need this for this demo, but I want to create it anyway, is to create an endpoint. Endpoints are simply how things talk to the SQL Server instance. So in this case, I'm creating an endpoint specifically for Service Broker so that a remote machine can send messages to this specific instance of SQL Server. So I call the endpoint EP_SSB, endpoint_Service Broker. You can name it really whatever you want, as long as it makes sense in your environment. State is started. It's a TCP endpoint set on listener port 1234. So the listener port is just the TCP port that this listener is going to be running on, or that this endpoint is going to be listening on. I can set it for any TCP port that I want, as long as it's not a port number that's already in use. So in other words, it can't be 1433, it can't be 3389, because that's remote desktop, it can't be 139, because that's the file share. So just basically pick a random number that's up high, and you should be fine. I can specify what IP address I want to use for this listener, or for this endpoint to listen on, or I can simply say, use all the IP addresses on this box. This is a DHCP environment, so I never know what IP I'm going to get, so I have to use all in this particular case. For Service Broker, I set my authentication equal to Windows and to negotiate the authentication. In this particular case, encryption is disabled. And then I've got message forwarding enabled. So having message forwarding enabled allows me to actually hop messages from server to server if I need to. So if I've got firewall configuration issues between a couple of servers, I may need to use some third server to actually route those messages. And I can do that through the routing functionality, which we'll look at when we get to the actual server-to-server communications that we're going to see in a minute. So there are a whole bunch of Service Broker object types that we have to create. If we just look in Object Explorer, we'll see there's a whole bunch of things here listed under Service Broker. So there's a U in the back. There we go. Whole bunch of object types. Now we're not going to create all of those, but we are actually going to have to use most of them. The ones we're not going to be using are broker priorities and remote service bindings. We're going to create message types, contracts, queues, and services right now. When we get to the second half of the demo, then we'll create a route, and that's how we actually send messages back and forth. Believe it or not, this is the reduced number of objects that we have to create. I talked to the guy that designed Service Broker, Remus Rashanu, out in the Redmond office at Microsoft, and he told me the initial spec for Service Broker had something like 15 different objects we were going to have to create. They were told that was way too many, so they pared it down to these 7. So this is the easy version. I nearly hit him when he told me that. So the first object we're going to create is a message type. Message types are, in Microsoft's tried and true fashion, a very poorly named object. Message types aren't actually defining the kind of data you're sending. All a message type is doing is defining the validation for that message. So in this case, I create a message type, I give it some funky long name. You don't need to use this stupid format that I use. The reason I use this stupid ass format is because when I first learned how to use Service Broker, this was the format of the object names in the code that I was reading, so I just kept using it. It sucks, I wish I'd never done it for my demos, but it's there. The upside to this ridiculous naming structure is that I've got application name, environment of some sort, and then the actual object name at the end. So this is all part of the application name right here. So this is handy if you really think about the fact that you may use Service Broker a lot across lots of different applications, sending messages between applications, because you need to avoid naming conflicts. The upside to this ridiculous naming structure is that I'll never have a naming conflict, because I always have the name of the application and then the name of the service within that application as part of the object name. On the downside, my object names are stupidly long. So there's the trade-off. Authorization for this to create this object is DBO, so it's basically the object is owned by DBO. And then I've got the parameter here called validation. Validation has 4 options: none, blank, well-formed XML, and then there's some ridiculously long one that says that the message body, or the data in the message, has to fit a specific XSD that's predefined within your SQL Server database. It's like that long, you have to type it out, it's a royal pain. I don't know anybody that's ever actually used that. Everybody I know uses well-formed XML or none, and they do all their validation of the data in the message in the application layer. So in this case, I'm using none. I am a DBA. I'm lazy by default, so I don't want to do any sort of validation. The next object type we create is called the contract. A contract simply takes one or more message types and binds them together into a logical, one-to-many relationship, so that I know which message types I can use when I'm sending messages. So in this case, I've just got one message type that I'm using. So it's just listed here, sent by any. I can specify which end of my conversation is allowed to use specific message types if I want. So I can have the sender or the initiator using one message type, and then I can have the receiver reply back with a different message type should I desire to. And I can lock that down so that messages can't be sent in the wrong direction through bad code. In this case, I know I'm not going to have any bad code because I've been running this demo for coming up on 4 years now. So I know the code is going to work. So I'm just going to use sent by any. If I needed another message type in there, I just do a comma-separated list, and I type out my next message type, sent by whoever, comma, next message type, sent by whoever. So the next objects I'm creating are the queues. So the queues are obviously what's going to hold the actual messages that I'm receiving. So you'll notice I've got two queues here up on the screen. I've got a sample sender and a sample receiver. The reason I have two queues is because whenever I send a message and close the conversation, I'm going to automatically get a message sent from the receiver back to the sender saying that the conversation's been closed. I then have to receive that message and end the conversation again. So we're basically doing a two-phase commit to actually end the conversation. Now, you don't have to use two queues. You can do all of this with one queue. The catch is that if you're using one queue and you have a lot of conversations being created and destroyed, the process or the stored procedure that's running through processing all these messages is going to end up with a lot of messages that it has to deal with that aren't doing any actual production work. Because say I create a conversation for every 5 messages that I send, and I'm sending 100,000 messages an hour. That's a lot of conversations to be building and destroying. Every time I destroy a conversation, I send an end conversation back into the queue that I have to process. So every 6th message, I'm not doing actual work. I'm simply ending the conversation. So we can offload all that work to a sending queue and not have to deal with any of it during our production workday. We do it, we process it after the fact or in real time or however we want, but it won't impact the speed of our actual data processing. So the next 2 objects that I'm creating are services. Services are what I actually send the message to. The service then takes that message and inserts it into the queue based on however the service is configured. So for these queues, I've got status on, retention off. The services, I create a service, one for the sender, authorization DBO, on queue, and I specify the queue that I'm going to be sending the messages into when they are received by the service, and then the contract that has to be used for this specific service. So whenever I send a message into this service, the message type that I'm using has to match one or more, has to match one of the message types that are specified by this contract. I do the exact same thing for my receiving service, sample receive service. On queue, sample receiver, on the specific contract. When I've got 2 services and 2 queues that I'm working with, the contract has to be the same between those 2 sides because we need the messages to be able to go back and forth on the same message types if necessary. So those are all the service broker objects I need to create. So let's look at how we actually send a message. So out of this stored procedure here, USB send message, this is the important part for Service Broker. All the stuff at the above, that is insert your business logic here. That does whatever you need it to do. So in this case, my business logic says that I simply am going to take all the rows out of sys.tables, of which there's 1 row, dump it into an XML variable, and send the value of that variable as the message. Fairly straightforward. So I have to declare this variable here, in this case I called it @dialogHandle as a unique identifier. This unique identifier is going to be the conversation handle. This is how I identify what messages go in my conversation. So the way this stored procedure is set up, you actually don't really want to do it in the real world. The problem with this stored procedure is that I'm creating a new conversation for every message I send. This is actually going to perform very poorly under heavy load because building conversations and tearing down conversations is actually fairly expensive. If we send a message on an existing conversation, it's going to be sent about 4 times faster than if we created a new conversation, and it'll be received about 10 times faster than if I had to do an end conversation afterwards. So if you're in a high-load environment where you're sending lots and lots of messages, it's very important to learn how to send all those messages under a single conversation. Fortunately, there's lots of code samples out there on how to actually do that, some written by me, some written by Remus. He actually likes mine better, which I love pointing out whenever I see him. So the first thing we need to do is create this conversation. So the code, the syntax here is begin conversation dialog, which you can shorten to begin dialog if you want. And then we specify the parameter, or the variable. So you'll notice I'm not setting this variable to anything. That's because this begin conversation dialog command effectively treats this as an output parameter. So it's going to stuff a value into this for me when this begin dialog service block runs. I send from a service. I undo the change I made. I'm sending from the sample send service to the sample receive service on this specific contract. So once I've built up my conversation, any message type that I'm going to use when I actually send the message in the next command has to be a message type that is part of this contract that I've used to create this conversation. I have to specify where I'm sending from because the acknowledgments that are going to come back saying the conversation is being ended have to have somewhere to go. So I need to specify that as part of the begin dialog. Once I've run this and I've got this conversation handle, I can use it as many times as I want. I can do send on conversation, specify the GUID, using message type, whatever message type I need to specify based on my contract, in this case, sample message type. And then I simply drop the value between some parentheses, and the message is then sent. So what a lot of people will do if they're going to send a lot of messages on the same conversation is they'll create a table in their system that's just got a few columns. It's basically got from service, to service, contract, and then a column for the conversation handle. Whenever they run the begin conversation dialog and get a handle, they'll simply insert a row into this table that's got the from service, the to service, the contract, and then they'll drop the GUID in there so that when they go through and send a new message on the same conversation, they simply just query this table, grab the value out of there, and use it in their stored procedure, just like any standard settings table in any database. So once I've done this send on conversation command, at this point, the message has been sent. I need to go look on my receiving side to process this message. So the code to do receiving is even simpler. It's this block of code right here. And actually more specifically, it's this block of code right here inside the outer block. So the first thing I need to do is declare a couple of variables. In this case, I'm declaring an XML data type variable and a GUID, which is my dialog handle, because I need to know what conversation to close. So we're going to ignore the wait for statement outside of the block here, and we're going to look at the inside statement for a minute. So in this case, we're doing a receive top one, and we're grabbing the conversation handle and the message body from this specific queue. So we're receiving whatever the first message in the queue is. Dropping the conversation handle and taking the message body, casting it as XML first, and dropping it into our two variables. If our dialog handle is null, I return 0. Nothing happened. This line here should say, insert your business logic here. Whatever you need to do with this data, at this point, you can do. The data is in your stored procedure. We then do an end conversation. So wrapped around this receive, I have this wait for statement. What this wait for statement does is it tells SQL Server when you're going to get this message out of the queue, get a message out of the queue. If there is no message to receive out of the queue, wait for however much time is specified by this timeout setting. And this is in milliseconds. So in this case, I'm going to receive a message. If there's no message to receive, then I'm going to wait for up to 1 second for that message to arrive. If a message arrives, I'll receive it. If no message arrives, I'll simply go to the next line of my code and bail out of my wait for statement. So that is why we have to have this block of code right here. If the dialog handle is null, then we simply have no message to process, and we simply bail out of the stored procedure because there's nothing for us to do. When the end conversation command is run, that's when it sends a message automatically back to my sending queue that says that the conversation's been closed and we can't use it anymore. So on our sending queue, we need to run some code to clean up all those messages and complete the closing and the termination of all these conversation handles. So we do that using the exact same kind of code. We simply do receives on that queue, get the message, get the dialog handle out, and then do an end conversation on the dialog handle. At that point, we've completed the two-phase commit, or the two-phase end conversation, and the data's all done and the conversation's gone. So let's go ahead and create all these objects. I shouldn't get any error messages. Okay. And let's go ahead and see what happens when we start running these. So here's my stored procs. Here's the two queues. Here's sys conversation endpoints, and here's sysjet transmission queue. So if we look at the queues right now, obviously there's no data in these queues. I've just dropped and recreated them. I cheated. Sys.conversation endpoints, nothing there. Nothing in sys.transmission queue. So let's go ahead and send a message. Message has been sent. So if everything is set up correctly and working, I've got one message sitting in my receiving queue down at the bottom, waiting to be pulled out and processed. So at this point, my app would either need to log into the database and run my stored procedure, or I would need to configure the queue so that it had an activation stored procedure, so that when the message first arrived, it would then do something with that message automatically. If I look at conversation endpoints, you'll notice I have two rows in here, even though I've only created a single conversation. And you can see that I've only got one conversation, because the conversation ID is the same in both of these rows. The next column here gives you a clue as to why there's two rows. Is initiator equals 1 or 0? What this is telling me is that because this is designed for a database-to-database or server-to-server messaging system, I need to account for that at all phases. So even if I'm sending messages inside the same database, I'm always going to get two rows in this conversation endpoints object for each conversation, because I have one for the sending queue, or sorry, one for the sending service and one for the receiving side of the service. So if I was doing server-to-server messaging, I would only have one in each side. I wouldn't have two in the same location. You can see I'm in a state of conversing. We can see what the FAR service is, and we can see what the local service is. And we can see when this conversation is going to die. So that is when the conversation expires automatically. So that would be 6/11/2081. If this application is still in use in 2081, I hope the conversation is dead by then, because it's been running for a very long time. We can see some various other GUIDs that for the most part we really don't need to deal with. And we can see some sequence information, and again, this is for the most part stuff we really don't need to deal with. There is an is_system flag, there are some system queues in things like the MSDB database. The reason those are there is because actually database mail in SQL Server 2005 and up actually uses Service Broker under the covers. So it's actually using Service Broker to do all that mail queuing. If I look in the transmission queue, I've got nothing listed in the transmission queue because I've got no messages that are stalled. So if I go ahead and receive this message, go away, Object Explorer. Go ahead and receive this message. My business logic has run. I have the data on the screen. So the message was sent successfully. We've run the end conversation command, so I should now see a message sitting in my sending queue. And I do. We know that this is an end conversation because if we look at the message type, you'll notice that that is not one of my message types. That is a Microsoft message type. That message type indicates that this is an end conversation message. It doesn't need to be a part of my contract because it's implicitly in every contract type. All these Microsoft message types are. If I look at conversation endpoints, we'll see that we still have 2 records here because the conversation still exists. In a production environment, I would configure my sending queue to use my USP_process_ACK stored procedure as a activated stored procedure. So as soon as those end conversation messages come in, I simply want to clear those out as quickly as possible. So I'd set up an activated stored procedure on the sender so that it clears them out right away. I run that, there's no business logic, there's nothing to do in here, it's simply ending the conversation. My queues are empty, and if I've talked for long enough, conversation endpoints should be empty as well. All right, so there's 1 record left in there. This record will get cleaned out at some point. There's a background thread that goes through and clears all these messages or all these records out of conversation endpoints kind of whenever SQL Server gets around to it. So SQL Server will clean these up at some point by itself. Obviously, there's nothing in the transmission queue because there's nothing going on. So we've now sent and received a message within the single database. Sorry, I'm looking at the clock at 20 minutes left. Just about enough time. So let's go ahead and look at server-to-server messaging. So when we're sending messages from one instance to another, all the code is exactly the same. All the objects are exactly the same. There's nothing special in here. The only thing that I've changed is I've added a route. So this route is just like a route in a networking configuration. So if you look at your computer, it's got network routes that tell the TCP stack where to send information. This is the exact same concept. This route is going to look to see if a message has been sent to this service name. It's going to then forward it to this server looking for a database with a broker instance of this value. So if I go ahead and connect to this server, which I've conveniently done right here, I can look and see what database that is that I'm sending to. So you'll notice I'm not specifying the name of the database that I'm sending to. That's because database names can change. So what I do instead is I send to a service broker GUID. So that service broker GUID you're going to find in sys.databases. And it used to be the 4th column from the left, or from the right rather. Now there's all this extra crap in here for contained databases. So kind of towards the middle now, you'll see the service broker GUID column. So in this case, service broker GUID column is sending messages into the AdventureWorks database on my second server. So when I'm setting up my routes, I simply need to go connect to the other server in the route that the route is sending messages to, and query sys.databases and get this value. Now you'll notice that some of these databases have a GUID of all zeros listed. This means that Service Broker was never turned on these databases. Turning Service Broker on is a fairly simple alter database command. Alter database, whatever your database name is, with enable broker or with new broker. If you do enable broker and it's never been enabled before, it will automatically switch it to new broker. So I simply use enable broker all the time. Because if I tell an existing database that I'm using Service Broker for that I want to initialize it with new broker, it's actually going to change this GUID, which means all the messages in flight and all the conversations I had open are now invalid and cannot be processed. Now on the flip side of that, if you end up with a bad configuration, if you're a consultant, you walk into a shop and they've got 50 million conversations open with no messages, or even if they have lots of messages, you need to go through and end all those conversations. The easiest way to do it is an alter database with new broker, because that's going to run immediately and it's going to come back right away saying that it's completed. And then there's a background process in SQL Server that's basically doing a deferred data deletion that's going to go through and clean up all those conversation endpoints automatically. That'll all take you about 1/3 of a second to do by using the alter database. If I needed to clean up 50 million conversations manually, just looping through one by one, closing them, that could take days or even weeks to do, depending on how fast I can run that cursor. So we've made this one change, we've added a route, and then you'll notice here I'm not creating the processing stored procedure that's going to do my business logic and receive out of my receiving queue. So let's go ahead and create all these objects, but other than that, this is all exactly the same. And I don't need that little snippet of code at the bottom there. So if you ever need to clean up all your conversations, a nice cursor is just how you do it. Select conversation handle from sys.conversation endpoints, and then just loop through it, killing all the conversations with the end conversation with cleanup. End conversation with cleanup is the same effect as running end conversation on both sides. We're just telling it we're going to run it once, and we're going to clean up all the metadata about that conversation right away. So we're not going to wait for the secondary commit. So now that I've run all that on the primary server, or rather on the sending server, let's look at the receiving server. On the receiving server, I have to create all the exact same objects, that I created on my sending server. So this includes all the Service Broker objects all need to be there, and they all need to have the exact same names. If they don't have the same names, the message won't be able to be received. So there's actually two things different in this stored proc. So endpoint's the same, all this other stuff's the same. Because when I first built this demo, I wasn't in a domain environment, and I didn't want to set up the certificate-based authentication correctly, because again, I'm lazy. I cheated. I did a grant control on service to public. In the real world, you would not want to do this. The other difference between these two scripts is the route is different on this script. So in this case, the route name is the same. With service name, in this case, whenever messages are sent to my sending service, the route's going to be triggered. So these are going to be the acknowledgments that are coming back to the original machine. If I don't have this route in place, my sending server will never be able to remove all the conversations out of its system without doing an end conversation with cleanup, because it's never going to get the acknowledgments back saying that the conversation needs to be closed. I specify the broker instance of the AdventureWorks database on my sending machine. Now there's no requirement that my database names are the same. In this case, they just happen to be. I then set the TCP address that I use to connect to the Service Broker endpoint on my remote machine. The only stored procedure I'm creating is the one to actually receive the messages. So create procedure, USP receive message. Other than that, it's exactly the same. All my sending and receiving code, nothing changes. So I'm always on 2, so let's go ahead and run this stored proc. And I'm going to go ahead and grab the code out of this file. So my objects are all created. I can now start sending messages back and forth. Oops. So this window here is connected to the sender. This query window is connected to the receiver. So that it's easier to figure this out, let me make these bigger. And remove the stored procs we're not going to be running. That way we can keep track of what's what. So on my sender, I'm going to go ahead and send a message. When I go ahead and query my 2 queues, I have no messages in queue. It's because the message has been picked up by the route and forwarded off to another location. If I look at conversation endpoints, I only have, well, I still have the old one, but I have the new one as well. So that should be the old one, this should be the new one, because it's the initiator. If I look at the transmission queue, go to the bottom. If I look at my transmission queue, that message should get sent fairly quickly. Why are we failing? So if this is going to crap out, eventually it'll give us a transmission status in there. So let's go ahead and look at the receiving server while we're waiting for that. We can see we've received 2 messages because apparently I can't click and press F5 appropriately in the right order. So I got a second message that got sent. So I've got 2 messages sitting in my queue waiting to be received. If I look at conversation endpoints, I see 2 conversations because I'm creating one every time I send a message. If I look in the transmission queue, there's nothing in there. So let's go ahead and receive these 2 messages. There we go. I've now received my 2 messages. If I run this again, I get that wait for kicking in where I wait 1 second and then it terminates. And we can see that it took 1 second based on how long Management Studio ran this query for. Ran for a second and then terminated. It's fairly common to set this for 1, 2, 3 seconds. You usually don't want it waiting too long because you don't want that thread sitting there idle on a scheduler, because this is chewing up a scheduler while it's waiting because it's constantly looking in that queue to see if something comes in. So if I look at the transmission queue, all right, everything's cleared out, the message has been sent. So I still have my conversation endpoints here. And if I look at my queues, I've got 2 messages in my sending queue. Knock it off VMware. So I'll run my acknowledgement twice. Run it a 3rd time, there's no message to process, everything's fine. Nothing in the queues. Conversation endpoint's still working on cleaning up this old piece of junk that's sitting in there. So what happens when, I got 10 minutes. What happens when I lose network connectivity? So say the 2 of us are doing business with each other, he's the supplier, I'm the customer. I put orders into my SQL server, my SQL server sends messages to him. Conveniently located halfway around the world in this case. We'll say there's a fiber cut on the Atlantic. His SQL server's still up, ready to receive messages. I'm trying to send messages. But because the fiber's cut across the Atlantic, we can't send messages back and forth to each other. So to simulate this, VM settings, network adapter, turn off. Server no longer has network connectivity. Go back to the other machine, verify that. You don't have to worry that the firewall is preventing this. I've got all the firewalls turned off, like every good database administrator that's written a book on security. I turned all the security off to make all this stuff work nice and easy. So we've got no connectivity. So let's go ahead and send a message and see what happens. We send a message, we look in our queues, we still have nothing in the queues because the message has not been delivered to a local service or to a local queue. We look in conversation endpoints, we see the new message or the new conversation listed there as well as that old piece of junk. We look at the transmission queue, we have the message sitting there. We see the conversation handle, we see where it's going, we see where it's coming from, we see the service contract name, we see when it was dropped into the queue. Keep in mind my VMs are all set for Pacific time. That's why things look a little funky between the queue time and the system clock. Message queue sequence number tells me what number this is in the conversation. So if I've got lots of messages on the same conversation, I'll have 0, 1, 2, 3, 4, 5, etc., 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 until it runs out of numbers. And I believe that's a big int, so you got lots of numbers to work with. Our message type is conversation error, is end of dialogue, and the message body. Now the reason I'm sitting here telling you what all these columns are that you could easily read for yourself is because I have to wait for this thing to time out. Once it times out, you get a nice error message. You can look up the error code if you want. It's listed right here, 10060, or you can simply just read the text that Remus was kind enough to put there for us. According to Remus, this is the most complex thing he's ever done in SQL Server, is getting these error messages to display here. The reason for that is because SQL Server is not designed to capture error messages. It's designed to throw error messages back to the end user. So he actually had to build a whole new error catching system into the database engine so that he could catch this error and display it for our convenience. I have thanked him for this on your behalf already. A connection attempt failed because the connected party did not properly respond after a period of time, or the established connection failed because the connected host has failed to respond. Translation, the fiber's been cut between my house and his house, and he can't get the message. If I send another message, it will just drop it into the queue. It'll end up in this transmission queue. This transmission queue periodically is going to try and resend the message. Once it's able to send the first message again, then it'll just dump everything across the wire basically as fast as it can. So you'll see this huge burst of network traffic if you've got a ton of messages queued up. So let's go ahead and turn everything back on. adapter, reconnect. So basically I'm just plugging the Ethernet cord back in, a virtual Ethernet cord. Ping always on 2. Connections reestablished, fiber's been repaired between our 2 offices. And if I query the transmission queue again, the message is already gone. I've had to do nothing, I've sent no new messages. SQL Server has simply periodically checked and gone, well, that's back, so let's deliver the message. If we look on our receiver, we'll see that message, once I get the network back up, we'll see that message sitting in the receiving queue waiting to be processed. We receive our message, come back here. Our extremely complex business logic has displayed the message on the screen. And then we can simply do the end conversation on this side over here. All fairly straightforward, all very easily recoverable because we don't have to do anything on our side. Now these messages and conversations are all fully logged operations. So if you do a backup and a restore to say a QA environment, any messages in queue are going to remain in queue. Now this isn't a bad thing necessarily. The good part about this whole process, when you restore a database with Service Broker turned on, Service Broker becomes disabled automatically. The reason that Microsoft does this is because we need to know if we want to actually process all the messages in the queue or not. So if we're restoring our production environment, we may or may not want to, depending on what messages have been processed. So we need to go look on our receiving system, if it's a separate server, or a separate database rather, and look and see what messages have been received on that side based on how the data is laid out through whatever checking process you want to do. If everything's in the same database, obviously none of this matters. If you've got the 2 databases and you've got messages that have been processed, you'll need to go in and manually receive them out of the Service Broker. So basically you need to remove the routes, let everything deliver to the local queue, receive the messages you want to get rid of, put the route back in place, and then just write some custom code that's going to receive those messages and resend them. That will then shoot them off to the remote side. Now, if I needed to do that whole server-to-server routing thing that I talk about, where you've got 3 servers and you need to bounce the messages through the one in the middle, all we do is we create all the exact same objects just like we normally would. We simply put 2 routes on that box. One that takes messages from the receive queue and forwards them on to the final destination, and one that sits on the sending queue and forwards those messages back to the original sending server. So we literally just bounce the messages through this box at this point. The good news is that middle box does not need to be a paid-for edition of SQL Server. You can use SQL Express for that should you desire to. The only requirement is that you cannot send messages from one Express instance to another. You have to have a paid-for instance of SQL Server in here somewhere. So you just got to pick where you want to put it, and then everything will work out just fine. That's the end of the deck, apparently. So we've got 2 minutes left. Questions? I know I went through a lot of code really fast. No questions?
Okay.
Yes, sir.
In SQL 2008, you need to exclusively log database to enable Service Broker.
Yes.
Is any better in SQL 2012?
So this question was, in SQL Server 2008, when you do an alter database enable broker, it takes an exclusive lock on the database. Is that any better in 2012? No. And I doubt it ever will be, because we have to do a meta operation on the actual database itself. So you do have to kick your users out. The upside is you only got to kick them out for like a split second. Just do an alter database with immediate rollback. They'll all roll back, your transaction will complete, and they can also come right back in. This obviously requires that whatever application your users are using understands the concept of reconnecting, which I'm sure they all do, because all our developers are all wonderful people that never make mistakes like that. But yeah, you do still need to take an exclusive lock against the database, unfortunately. The upside being, of course, you have to do that once. And once it's done, it's done.
The same problem is with mirroring. You need to unmirror database.
If you want to run alter database and turn mirroring on and off, yeah, I believe you do still need to take an exclusive lock with mirroring. Mirroring hasn't changed any from 08R2 to 2012 since it's deprecated. They're not going to spend any money on it, and just developer time is money until they rip it out. That's the only time they're going to spend any money on it. So yeah, you still need to take an exclusive lock there. Now, one thing I did not mention is that the routes in Service Broker do support database mirroring. They also are fully supported for things like always-on availability groups as well. So if you just create the endpoint listener on all IP addresses, when the availability group listener comes up, it'll simply start listening on that IP address as well, so you can send messages to the availability group listener. If you're using mirroring, there's a mirror to parameter that you can specify for the service. So you just specify both the mirror and the partner. Whichever machine is active on database mirroring is where the messages will be routed to as part of the service. So, any other questions?
I have a question
Yeah.
about query notification.
About
Query notification.
query notification. Okay, I'll try.
Is there any possibility to set up query notification to use existing conversation? Because every time if we register our SQL query for notification, SQL Server open new conversation.
So this question is, if I'm using query notifications in SQL Server, is there any way to tell that to use an existing conversation? I don't think so. I've only used it a couple of times and it's always been in low load environments. I would have to take a look at the syntax, but I don't think there is. Unfortunately, yeah, which is a real pain when dealing with it.
We open new conversation, we must end conversation, open new conversation.
Right.
It's big load for SQL Server.
Yeah, it is a bunch of load on the SQL Server, unfortunately. And I don't think there's a way to do it. If there's not, there should be. If you shoot me an email, I'll look into it and find it. And if it's not, I will go tell the guys that built this stuff to add that in, because that's actually a really good feature. So I'll check. I can check Connect and see if there's a bug request in there for it already, and if there's not, I can add one, and then go poke the guy in Seattle that's actually going to do the work until he actually does it. So we are all out of time. I thank you all very much for coming, both to the session and to the conference today. Don't forget to thank the sponsors that are here. I don't know if anybody's told you that yet today, but these events don't happen without sponsors, because frankly, this place ain't cheap to rent out for 3 days. And the sponsors are what make all this happen. So thank you all very much for coming. I do appreciate it, and I hope you have a great rest of the day.